Hi there, it's David here again, and I'm going to continue my very successful series of lectures. And this next amazing one will be me, off the bat, off the cuff, trying to explain what an orbit is. Yes, orbit. That's saying that these things float round the planet, satellites and the moon and that sort of stuff. I'm going to try to explain this. So, there's things up there, satellites and spaceships and things, and they're going around the Earth. And we say, oh, that's them in an orbit. You might wonder, what is it that's keeping them spinning around like that? Why don't they just fall down? They seem to go round in a circle all the time and keep the same distance away. Very odd behaviour that. Why don't they just crash down? What's keeping them up there? What is an orbit? Why doesn't it just fall down like a stone? If you're on the surface and you throw a stone up in the air, it doesn't start circling around, it falls to the ground. Shoot a bullet out of a gun. Very fast bullet. Goes along, across the surface of the earth, and then dips down, hits the ground. Goes in a kind of curve. So what's keeping these things that are high up there, what's stopping them from falling down and bouncing off the ground? The answer is the sideways movement. They are actually falling. They're falling down. That's exactly what they're doing. That's what an orbit is. It's something which is falling down. But as it's falling down, it's going very fast laterally or sideways. And because of that, as it's about to fall down a bit, the surface of the earth below it curves away. So it stays the same distance away. It just keeps falling. Because it's travelling sideways, as it gets to a new bit, it falls a bit more. Well, the earth equally curves down. So as it's falling, the earth's curving down, and it just continues to fall. And it falls like that forever. Well, not almost ever, but it keeps going for quite a while. Now, if you shot a bullet out of a gun, it would go very fast and start curving, and then it would hit the ground. If you shot it fast enough, if it was going fast enough, then it would keep curving. As the bullet was coming down towards the ground, it would meet a curve and go over it. But because of the friction of air, then we can't keep up the pace, or the bullet would just burn because of the speed it'd have to go at. But when you go up into near space, the first part of space, you're through the atmosphere, so you no longer get any friction of the atmosphere, which means you don't heat up by the speed you're going at. So you can go at incredible speeds, and this allows you to match the curvature of the earth. So as the satellite is essentially dropping like a stone, it's exactly matching the earth. So as it drops, say it drops 1,000 feet, the earth curves away 1,000 feet. If it goes sideways by a mile, it will find down below it the earth has dropped and curved by a mile. So it's dropping all the time, it's falling out of space, but it's got such a sideways movement that the fall and the curve match each other, which means it just circles around and orbits. Eventually that orbit will deteriorate, but it will take an incredible amount of time, but it is deteriorating, and eventually things will crash down onto the surface, but it can take a very long time Now, if we think about the moon and the Earth, we have a very unusual situation here, because we think that, and we're being led to believe that the moon is orbiting the Earth. Not true. You might think that, and we're being told that, and we've learned it. But in fact, the moon is not orbiting the Earth. What the moon and the Earth are doing is spinning around each other. They're a binary system, which means that they both spin around a focal point between them. The centre of gravity is between the Earth and the moon. It's in space. And what they're doing is spinning around that central point in a binary relationship. The moon isn't spinning around the Earth. They're both spinning around each other. And their centre of gravity is off the surface of the planet, which means they're linked intrinsically. And that's why life appeared on Earth. And that's why humans exist, because without the moon, we could never have existed. And we get tidal forces, and people will usually associate tidal forces with water. In fact, there's a lot of places on the Earth which are vast expanses of water, and they don't move with any tide. Very difficult to explain that one, because why is it some bodies of water move with tides and other bodies of water are completely still, don't seem to get affected? Another factor is that possibly people don't think about too much, and that is there's a tidal effect on the Earth, on the ground, on the solid matter. So the Earth itself gets pulled around by the force of gravity. It changes the actual tectonic plates. It pulls the Earth around in the way that it pulls water around. In fact, it pulls it even more because there's more density at times. So therefore the Earth itself is changing shape as the moon on the ground, as the moon goes round, as they spin round each other. So we have tidal effects on mountain ranges and large areas of land as well, as it shifts the ground around. So this can affect the height of a mountain. This is why I always wonder why they give you the height of Everest to the exact feet. Doesn't seem to make sense to me, because where's the bottom and where's the top? Because they're shifting about. So the Earth and the moon are a binary system. An orbit really is something like a small thing that goes around a large body. And it's very unusual for a moon to be the size of our moon. Moons in the solar system tend to be really small and a planet really big. And the moon has amazing connections with all the different relationships between the sun. You know, it's 50 times smaller in vision than the sun. So therefore that's why we get these eclipses of an incredible coincidence. So what happens when science can't explain something? They become coincidence theorists. They say, yes, just yet another amazing coincidence. What they mean is, this is highly unlikely, but we can't explain it. The odds against it are astronomical, literally. So they just say, yeah, yet another amazing coincidence, rather than admit they don't even know. So scientists often are coincidence theorists.